astronomy and physics. He's now in the third year of his doctorate, studying the interaction between stars and the planets that orbit them. And tonight, in Are Space Missions Beneficial to Humanity?, we will discuss the benefits and promises of space exploration and argue why investing in a space program is in fact a rewarding endeavor. So thank you.
Thank you very much for coming, especially given the gloomy weather that was mentioned. Unfortunately you won't have the telescope observing, but hopefully you'll find this a rewarding experience nonetheless. Can everybody hear me in the back as well? I don't know if the mic is working or not. So the title of today's talk asks a question which might seem to have an obvious answer to some of you, but it is still a very important question to ask. Whether you think the answer is yes or no, and I'm sure most of you have an answer in mind, asking this question can result in one of two things. It will either reaffirm your position and give you some strong arguments to support that, or it will cause you to rethink the situation and potentially change your mind. I will be arguing that the answer is a definite yes. There are plenty of benefits to spending both time and money researching space, creating spacecraft, studying our solar system, and so on. And today I'll talk about just a small example of the many benefits that come from that. One of those benefits, it comes from the technology required to achieve the goals of space research. Every mission into space is very complicated, be it something as simple as sending a cargo ship to the International Space Station, or something even more complicated, such as landing a robot on Mars. All of these missions involve technical innovations, which then, through clever thinking, are applied to applications on Earth, and all of us benefit, even though we don't actually end up going to space. Another benefit is that our environment that our planet is in, the solar system, is not as clean as some might think or generally tend to forget. People tend to focus on the big objects in our solar system, which is the sun at the center and the 8 planets orbiting around it. But there are plenty more objects in the solar system, such as comets, asteroids, and so on. These objects pose a potential threat to our existence. And studying those objects is very important for the survival of mankind. And finally, I'll talk about our own lives on Earth and our impact on it. In the modern world, we rely heavily on technology. And technology helps us in many aspects, be it to achieve goals that we wouldn't be able to otherwise, such as going to space, or it simplifies different things that would have been much more difficult to do. The problem is that the same technology which simplifies our lives also creates a lot of problems, be it for us personally or for humanity as a whole and the environment that we live in. However, the good thing is that the same technology can also solve the problems that it creates. And I will talk about that as well. The first thing I want to talk about is technology derived from space. And I'll talk about a single example, which is the Canadarm2. This device, which was created in Canada by McDonald de Twiller and Associates, in nearby Brampton in fact, is Canada's contribution to the International Space Station. And it allows Canadian scientists access to the vast resources on board the orbiting laboratory. Now this on its own is already a great contribution because those experiments are beneficial. But the benefit of this goes further. Now a bit about this device is that it has a structure similar to a human arm. If you look at the 3-joint structure on top, that can be thought of as a shoulder. There's a single joint structure in the middle, which you can think of as the elbow. And then again, there's a similar 3-joint structure on the bottom, which acts as the wrist. But the innovative thing about the Canadarm2 is that both ends can act as the wrist and the elbow, allowing the arm to travel across the space station and assist wherever it is needed. It is not fixed to a single location. The purpose of the Canadarm2 and the uses of it are many. Originally, it was meant to build and assemble the International Space Station, where it allowed to help attach all the modules. Currently, now that that's done, it assists in catching unpiloted cargo ships, which we can see an example of which in this image, where the Canadarm2 is catching HTV-3, which is a Japanese cargo ship, which routinely brings resources and equipment to the astronauts on board the station. As well, the Canadarm2 assists with maintenance operations outside the station, where it doesn't only bring equipment to the astronauts, but also holds on to them so they don't float into space while they're working away. Now, this innovative technology was originally built to work 400 kilometers above Earth, but it does have some very important applications here on the ground as well. And one area in which it has already found an application is in the area of neurosurgery. Oh, almost skipped this. So, the Canadarm2 is operated by astronauts on board the International Space Station. Wouldn't want to skip this interesting video. And here, this video shows us Canadian astronaut Chris Hadfield as he operates the Canadarm2 to unload some cargo.
We are extremely lucky not only to be able to live and work in this place, but also to be the people who operate Canadarm2. Canada built Canadarm2, and Canadarm2 built this space station. Everybody should be proud of that.
So as you've seen, astronauts on board the space station control the Canadarm2 with joysticks and devices similar to what you might use in a video game. And the 7 joints that I mentioned allow for vast maneuverability of the arm, allowing it to maneuver around the space station and deliver cargo to wherever it's needed. Now let me get back to what I was rudely saying before, the application of the Canadarm2. The area of neurosurgeries, which are surgeries on the brain, work in that the neurosurgeon tries to be as little invasive as possible, meaning making small cuts to the brain in order not to damage healthy tissue, while trying to reach as deeply as possible to fix the damaged tissue. The problem this causes is that the surgeon has very little visibility as to what they're actually doing inside the brain. Even though we might expect neurosurgeons to know the brain inside out, it is still very important in a delicate organ such as the brain to be able to see live what it is you're doing. And one instrument that allows surgeons to see inside the brain is a magnetic resonance imaging machine. These machines, when you can see an example of this on the right here, they're very bulky, which means if a surgeon wants to incorporate this machine into an operation, it means they will have to stop operating, slide the patient in, take the image, then slide the patient out, look at a printout of the image, and then continue operating based on this new information. As you can imagine, this is not only disruptive to the flow of the operation, but also very time-consuming, and hence far from ideal. What surgeons would ideally like to do is to be able to simultaneously see the brain and operate on it precisely. And this is where technology derived from the Canadarm2 comes in the form of NeuroArm. This remotely operated robotic surgical arm is small enough to fit into a MRI machine, magnetic resonance imaging, as well as it's made of such material that do not disrupt the magnetic field inside the machine which is required to take the image, thus allowing surgeons to do what I just said. Operate on the brain very precisely while taking images and seeing what it is they're actually doing. Now the operation of the neuroarm uses controls that mimic the actions that the surgeon would have taken if it would have been them actually operating on the brain. Therefore, it's quite intuitive, at least for people such as neurosurgeons. And in fact, it actually sends sensory signals so it can mimic the feel that the surgeon would have while operating. So it almost works as like the surgeon is operating themselves, but giving them that edge of being able to see inside. And this very clever device was developed by the same company that created Canada-Arm 2, along with collaboration with neurosurgeons at the University of Calgary. Since 2007, when it was launched, it has already helped dozens of patients and the surgeons operating on them. And it is so successful that there are plans to expand its use to other hospitals around Canada and potentially the world. Including one example close to home at the Hospital for Sick Children here in Toronto, where they're working on a small version of this that can be used on kids, and you might guess what it's going to be called? Kids Arm. Now, all of these contributions that Canada has done to both the International Space Station and neurosurgery are worthy of remembering. And very soon you won't have to look far for a reminder, but in your own pocket. Thanks to the new $5 bill, which depicts both the Canada-Arm 2, as well as some other Canadian contributions to the International Space Station. So keep an eye out for a wallet near you. Now, unfortunately, in the world that we live in, dangers to our health do not only come from the planet that we live on, be it from natural disasters or health risks, some of which can be cured by devices such as the neuroarm. The environment our planet itself is in, the solar system, is quite dangerous itself. And this became blatantly obvious on February 15th of this year. What you've seen now is a video of the Chelyabinsk meteor entering our atmosphere, burning up, and then exploding about 20 kilometers above the Russian city of Chelyabinsk. Now this meteor was quite small, only about the size of this room, maybe a couple times taller. But the explosion that you just witnessed was more than 10 times stronger than the nuclear bomb that was dropped on Hiroshima during World War II. So quite a strong explosion. Thankfully, however, the injuries that it caused were quite minor. Just a few shattered windows and people injured by the flying glass. But it's very important to remember that the damage could have been far worse. Had the meteor been just a few times larger, it could have actually reached the ground and obliterated the city of Chelyabinsk. And had it landed in the ocean instead, it could have caused a devastating tsunami, which would have been horrific to the surrounding nations. What we should do is learn from this minor incident, same as you might learn if you were to ride a bike without a helmet, fall, hit your head. You know, as smart human beings, that you should not just pick up your bike and continue riding. And the next time you should put on a helmet and ride with that, because the damage could have been far worse. Similarly here, our consequence is to understand that we must invest time and money researching asteroids, observing them, and then tracking their motions to spot potential dangers in the future. So this doesn't happen again, and if we do have a rock flying towards us, we could do something about it potentially. In this area, Canadian innovation steps in again, thanks to the Near-Earth Object Surveillance Satellite. This suitcase-sized telescope was launched a mere 10 days after the Chelyabinsk meteor. I'll give you a hint, it wasn't a coincidence. It was a coincidence. It would have been amazing to create such a thing in 10 days, but no. So it was just a coincidence. But its sole purpose, and it is the first telescope to do so in space, that is primarily there to detect asteroids and track their orbits. Again, so that if an asteroid is heading our way, we could find it as early as possible. The reason we need to find asteroids as early as possible is because dealing with them would require a lot of planning, a lot of research, and a lot of time to actually execute the mission. And there are a few ways of going about doing this. One method, which is the most popular one, and it was especially popularized by the Hollywood movie Armageddon, which requires an atomic bomb to blow up the asteroid. In this movie, if you haven't seen it, NASA sends a team of highly unqualified astronauts. Yes, you all seen the movie then. I'll give you a quick synopsis. They send a team of, well, doofuses onto the surface of the asteroid. Those people dug up a hole, planted a nuclear weapon, and then when it exploded, the asteroid blew up into two pieces, and then in a very Hollywood-like fashion, the two pieces hit the Earth by a few kilometers. Now there are a few problems with this scenario. First of all, nobody would ever send humans with a nuclear weapon on board an asteroid. That will definitely be a suicide mission. Furthermore, if you were to do that, there's no guarantee that this would actually happen. It is more likely that scenario B would occur, meaning instead of having to deal with one asteroid, you're left to deal with two asteroids. And then you need to round up two teams of doofuses to send on board those asteroids. Furthermore, you don't even know how many pieces the asteroid will break into. It could break into 5, it could break into 10, you have no idea. Therefore, that would only create further issues. The only way a mission like this could be executed is if you could guarantee that the asteroid will be completely obliterated, meaning breaking up into small pieces, such that if those enter our atmosphere, they would burn up and then at most cause minor damage. But the problem is, in order to guarantee this, we would need to know every single detail about the asteroid. Its structure, its mass, what it's made of, size, and so on. So I think this way is not the way to go. A better way is to try to divert the asteroid from its course so that once it actually reaches Earth, it is not heading directly towards us, but slightly off, such as right here. And the way to do this is by colliding the asteroid with a spacecraft. This would work somewhat like a football player tackling a rival football player that is heading to a touchdown, except in this case, the rival football player weighs about 200 times more than the CN Tower, and the touchdown is unfortunately the Earth. In order to test whether or not this sort of mission is possible, the European Space Agency is planning a test mission, which they call Don Quixote, after the Spanish tale in which, some of you are familiar, I see, a Spanish tale in which a knight charged against a windmill thinking it was a giant. And in this case, the knight will be a spacecraft and the giant will be a giant piece of rock. Now the asteroid they chose is harmless, it is not heading towards us, but they want to test whether or not they could deflect it enough so that in a real scenario it will deflect by a large enough distance to miss Earth. And this is how that is going to play out. This mission is still a concept, but they project that by the end of the decade they will be able to launch it. So the spacecraft is made up of two pieces, two parts. The first part is the orbiter, which will be sent to the asteroid. It will orbit around it for a period of a few months, study every single property it can about it, things like mass, size, shape, density, rotation, and so on. Once enough information has been learned, the second part, the impactor, will be sent on a collision course with the asteroid, where the specific speed and direction will be predetermined. The impactor will fly to the asteroid and collide with it, giving the asteroid its momentum, meaning pushing it into the direction that is needed. And this collision will hopefully push the asteroid off its course just enough so that by the time this hypothetical asteroid reaches Earth, it will miss us, as opposed to heading directly at us. I just show you two of the many different ways there are of dealing with asteroids. Scientists have proposed many different techniques, some of which are plausible, and some of which aren't. For various reasons, most of them via technological reasons, that we just don't have those in store. But I hope that when the time does come for us to deal with such a situation, that the nations of the world will be able to agree on a single solution to deal with the asteroid, and no time will be wasted on arguing whether we should hit it or blow it into pieces. And we can all agree on which way the Americans will go. Now, okay, no, Americans. Now, whether or not there is an asteroid heading our way, studying them has plenty of other applications. And to understand the further application I want to mention, we need to look at our modern world. In the modern world, we rely heavily on technology, as I mentioned, be it in the form of cell phones, or laptops, and even smart refrigerators. All of these smart devices contain a microchip, which is primarily made up of silicon, as well as some other metals. And the list goes on and on in our reliance on natural resources. For example, platinum is used in catalytic converters. And in fact, every single metal you've heard about has some use in the modern world. Excuse me. This reliance on natural resources is good for us, but it does create some problems. And the problem is with the depletion of these resources. Now let's look at this further. If we are good humans that recycle, we put our electronics in the blue bin, if that's how it's done in your town. But the unfortunate fact is that only 20 to 50% actually ends up getting reused. I'm referring now to the resources that are of interest. The sad truth is that up to 80% just ends up at a landfill. And this is what actually gets recycled. Let's face it, many of us don't recycle at all, and then all of this, 100% of these materials end up at a landfill. The problem with that is, once it ends up at a landfill, it is completely lost. No company will waste time and resources rummaging through a pile of garbage just to extract a little bit of resources. It's far more beneficial for companies to find new places to dig on Earth and extract new resources. And that creates a problem, because many studies recently have suggested that we have as little as 50 years left for the amount of resources that we have. Each resource, of course, has a different time frame, and some of them actually even less. Now, whether or not you believe these estimates, it is obvious that we don't have an unlimited amount. And here's why. The structure of the Earth is as follows. At the center, we have a solid iron core, surrounded by a molten iron outer core, then the mantle, which is made up of molten rock, and then a very, very thin crust. The crust is where the oceans and the continents exist, and where all of the resources that we rely on as well. But this wasn't always the structure of the Earth. Early on, a little bit after the formation of our planet, it was extremely hot. And when it was extremely hot, it was fully molten. What happened then was that heavy materials sank to the center, same as a rock sinks in the ocean. That's how we end up with the iron core. The problem for us is that most of the material that we're interested in, all of these metals, they bond with iron. Therefore, when iron sank, so did these materials. And the surface ended up being pretty much depleted of these resources. Now you might be asking, where then did all of these resources that we use come from? And the answer is from asteroids. Asteroids contain all of the resources that we're interested in. Silicon, platinum, and even water. And mining asteroids is now seeming to be a possibility. Even though it is a concept that existed for many decades, primarily in science fiction. For example, in the movie Alien, the team that discovers the alien first is actually heading back to Earth from a mining operation, from an asteroid. And this picture on the right is an image from the 1970s of asteroid mining operation based on a NASA conference that was held at that time. So the idea has been in place for many, many decades, but only now has technology caught up enough to allow us to accomplish this. And there are two ways about going to do this. One is to send that team of doofuses, although in this case, we'll send a reliable team. Or we can send a robot. The advantage of the human team is that humans are far better than robots in dealing with unpredictable circumstances. As we can imagine, going to an asteroid might pop up some unexpected problems. And humans would be able to deal with it far better. The problem is, it would be far too dangerous to do so. Therefore, we must rely on the robot. This robot would have to go to the asteroid, extract rock from it, process it, and bring back the materials to Earth. Clearly, we don't have this specific technology yet, but we do have the foundations for it, and if a mission like this is to be undertaken, it will require some innovation, but as I showed you from the first example, that's a good thing. Now, the benefits of actually accomplishing this are great. There's a benefit to humanity as a whole, because it will allow us to sustain the lifestyle that we have grown accustomed to, but maybe perhaps more important than that is we would be able to sustain it without damaging our environment. As you might know, every time a company digs up a new mine, it has to ruin the surrounding environment. By stopping doing this on Earth and moving this operation into space, that will no longer be the case. There is a benefit here to the companies that will be involved in this operation, and that benefit is financial. You might not care, because you might not own a company that is involved in this, and if you do, good for you. But what we should care is that private companies do tend to be slightly better than government agencies in reducing costs and innovating, given that they don't need to follow bureaucracy, and let's face it, they're playing with their own money, so why should we care? And finally, there's a great benefit to future exploration of the solar system. This benefit comes from the water I mentioned exists in asteroids. Water is important because it makes up the fuel used for rockets. Rocket fuel is made up of liquid hydrogen and liquid oxygen. When combined, they do create water, as well as a huge amount of energy, which pushes the asteroid forward. The rocket. The problem is that leaving Earth is very, very difficult. That's why every mission, every launch that is undertaken, up to 50% of the weight of the rocket is wasted on fuel. That is how much fuel is needed just to get the rocket away from the Earth. And the reason for this is quite simple. One comes from Earth's gravitational field. And in order to understand this, if I wanted to get this piece of chalk off the surface of the Earth and threw it with a certain initial speed, you can see that it reaches a certain height, but then drops back down. If I throw it with a faster initial speed, you can see it reaches a higher height, but then it still comes back down to me. You can envision that if I threw it progressively faster and faster, it will reach higher and higher, but still return back to Earth. Eventually, however, it will reach such a high height, so far away from the Earth, that Earth's gravitational field will be too weak to bring it back down. And this chalk will have escaped Earth. The speed that it would have to travel is the escape speed of our planet, which is extremely fast. In fact, it's 11 kilometers per second. So imagine going from here to roughly Mississauga in a single second. Now at this great speed, which already requires a lot of fuel to get to, there is another problem. And that is the rocket needs to fight air. man drives the car, the more his face gets deformed. The same forces that deform his face act to stop rockets from flying in the air. And again, the faster a rocket moves, the stronger this air resistance is. Therefore, we need to use even more fuel to not only get the rocket into the speed that we want, but also to keep it at that speed. And that is the reason why a lot of fuel is wasted. However, there is a solution here. If we could have fuel already in space, for example, in orbit around the Earth, all a rocket would have to do is get to orbit, which is far easier than completely escaping the Earth. By doing that, it will be above a large enough portion of the atmosphere. There it could refuel and head off to whatever destination it is planning to. This is possible if that robot that I mentioned that will extract resources from the asteroid will also bring back the water and keep it in orbit, where whatever techniques are used to turn water into rocket fuel on Earth can be used there, and we would have a refueling station around the Earth. In fact, there are even thoughts that a spacecraft could go to an asteroid, mine it by itself, and generate fuel on the spot for an even further destination. This idea is, of course, in its infancy, and who knows how long it will take, but it is possible, and one day it will allow us to explore the whole solar system with ease, or at least far easier than it is today. In conclusion, I've mentioned several applications and benefits of space, both exploration and research. One of it comes from the technology associated with getting to space and studying it, where this innovative technology is then applied to earthly benefits, benefiting the rest of us. It helps us to protect ourselves from the dangers of the surrounding solar system, or at the very least, let us sleep in peace knowing that there are no dangers coming our way. And finally, it gives us a source for new minerals, new resources, and so on, such that not only can we stop worrying about depleting the resources on Earth, but also we can stop destroying environments on our planet but still sustain the same lifestyle. Therefore, we should continue supporting the work done by space agencies around the world, as well as some of the private companies that are working towards similar goals as well. Thank you.
Yevgeni, that was a great talk. Does anyone have any questions? We've got some time.
This is the first case.
Is there any idea right now that many of asteroids are coming soon to our Earth?
Nothing that is headed directly towards us, but there is an asteroid that we know its orbit so well, the NASA has actually determined that it has a fairly good chance of hitting us in the 29th century. So nothing anytime soon. Yes. Sorry? Mm-hmm.
A lot of natural resources used for technology are in the core of the Earth.
Mm-hmm.
So what have we been using so far? Are they going to remain for any costs or?
Mm-hmm. So what I mentioned was that in the early stages of the Earth, a lot of those resources sank to the center of our planet. And the resources that we use today, we believe, came from asteroids. So throughout the long history of the solar system, the long history of Earth, which is about 4.5 billion years, the numerous collisions that we had from asteroids slowly enriched the crust with all of these resources.
So someplace like Saturn got hit repeatedly or got hit as well?
Well, so that one was a big hit. But I imagine throughout the history of our planet, we had plenty of those hits, many of which probably have erased their tracks. Yeah.
Is one way of dealing with asteroids having them hit water instead of collide with land?
So the problem with that is if it hits water, it creates tsunamis. So then, instead of being a local problem, it becomes, spread out. So that wouldn't be a way to go about it. You would want to deflect the asteroid completely from the planet. Yeah.
There's one thing about trying to catch an asteroid and holding it in orbit. Is that the plan you're talking about, the one where they want to hit it? They want to catch it on the orbit, or is that a different thing?
Was the purpose there to stop a hit or to use this resource?
I just heard the concept of catching an asteroid in orbit.
So I may have heard, I might know what you mean. One of the ways of extracting resources from asteroids was instead of sending a robot that would extract the material on the spot, it could potentially bring the asteroid into Earth orbit, and then since the asteroid would be so close, it would be very easy to ferry material from it. So that I've heard of something like that. That might be what maybe that's what you mean. Yeah?
When you're talking about mining asteroids, it's not some random asteroid that's going by, but something in the asteroid belt which is essentially stable, right? Like those aren't flying around or out or...
So the asteroid in the asteroid belt are not the only ones that exist. There are a lot of near-Earth asteroids, asteroids that have orbits that cross our own or very close to it. Those are actually the ones we need to worry about hitting us. But those will be the target for these missions, just because they're much closer than the asteroid belt. But definitely, it wouldn't be randomly picked. They would choose an asteroid that has the resources that we need, and definitely making sure they don't change its orbit in any way to cause any collisions.
So how does that any resources out in the water?
So comets, the center of them is made of rock. So that could potentially contain similar resources, yes.
How common is the asteroid to hit Russia? And how frequently has it happened, say, in modern times in the last 100 years?
So statistic-wise, that size of a meteor hits about every 50 years.
Really?
So that's, throughout the history of our planet, that's roughly how often it happens. Yeah. It's hard to know exactly because as you've seen, it doesn't even hit the ground. So if it were to happen over a forest or above the ocean, nobody would even know that it actually happened. So these kind of events are hard to track, but it's about 50 years. Yeah. No. The interesting thing is that on the same day, there was a different asteroid that was passing us. That one was predicted. This one came by surprise.
About how big of an area does the DEOS detect objects?
That's a good question. It actually tracks the region around the sun as we orbit around it. So roughly, I believe, 15 degrees on either side or something like that. But overall, in a whole orbit, it could actually track all asteroids throughout the solar system, or at least, it's tracking only the ones near our orbit. So the area is actually old. Yeah.
Are there any negative implications of asteroid?
So you can suggest plenty of negative implications, of course. One, let me think. Well, so mining it would not be altering its orbit. Hopefully it will be done in such a way that you're just extracting resources and bringing it back. Definitely the method of bringing the asteroid into orbit around the Earth is a bad idea. As far as actually going to it, extracting resources and bringing them back, other than flooding the market with resources, which would only affect companies and not us by making the resources very cheap.
Would you expect that to be extremely expensive?
To do in the first place, yes.
So I would figure whatever they bring back won't.
Yeah, so that's one of the suggestions why this is a bad idea, again, for companies. Because the idea is they would have to invest a lot of money, bring in these resources, and by flooding the market, it would drop the price. So of course they will think of some way of going about changing this, But again, I can't see any damage to society. These are sort of the big wigs that to figure out how they manage their own funds. Yeah.
Well, why just the asteroids? Why not the moon?
So the moon is also a possible destination for mining. The issue there is that the same thing that happened to Earth happened to the moon as well. So most of the resources are in the center of it. But similar to the Earth, there are of course resources on the surface given the large collisions of asteroids. But yeah, it's definitely another possibility. Especially for the water. It is believed to have water on the surface, so that could be a good fueling station. Yes. Exactly. Yeah. So we want to do it as early as possible because as you can imagine, small little spacecraft won't have a large effect on an asteroid. So it will be a small diversion which will have to accumulate with time. Yeah.
So that diversion thing, whatever it's called, it would be orbiting around Earth to wait for something to be spotted? I mean, I can't imagine the time lapse would be.
Do you mean the mission to divert it or the telescope that studies?
No, the diversion thing.
Yeah, so
Would have to be waiting for a danger to be spotted, right?
So this would only be deployed if a spacecraft such as the Near-Earth Object Surveillance Satellite, if I ever get there, if this, for example, satellite ends up spotting an asteroid heading our way, then that is when this sort of mission, Don Quixote, would have to be applied to a real dangerous asteroid as opposed to non-dangerous one as it is in this concept.
But it would have to be built and waiting on it.
Yeah.
Oh, okay.
Yeah, so that is the idea. So this will be tested, and then if it will be shown that it is possible to deflect an asteroid this way, then the idea would be to have a waiting concept like this so that once a danger is detected, it can be launched as early as possible. Yep.
As you mentioned before regarding the asteroid here in the Chelyabinsk, and I heard a lot of people are selling those small pieces from asteroids. Is that can be dangerous to your health?
No. No, there's no health risk involved, unless you eat it, but there's no reason to do that.
All right, I think we have time for one more question. Okay, so